welcome to the Oldfield Consultancy AI podcast. Today we've got with us Murray McMoney. Murray, how are you doing?
Very good, thank you. Thanks for having me on.
It's an absolute pleasure. And today you're here to discuss the paper that we've co-authored together entitled The Future of Condition-Based Monitoring, Risks of Operator Removal on Complex Platforms. Do you want to just give everybody a bit of background about who you are and what it is you currently do, and then we'll discuss the paper?
Yeah, of course. Yeah, so my name is Murray McMoney, as you said. I am a marine engineer and nuclear engineer in the Royal Navy. Have been now for 9 years, and I am been very interested in condition-based monitoring, and from that I became quite interested in automated systems and artificial intelligence, and that raised quite a few questions within that area. So I've kind of focused on that in the last couple of years, and really looking at the involvement of automated systems and AI systems within engineering platforms.
So what was it initially that kind of prompted you to start writing about this topic?
So initially, it was actually started from a project that I was doing as part of an MSc, and I was looking at how we could better understand material state to inform our maintenance packages within complex engineering systems. And I looked at a number of different factors that affected how systems degraded and how we could predict systems degrading. And clearly, one of the things that really came out of that was the development of condition-based monitoring systems and the development of modeling to be able to predict better when systems may fail. And really, that started to open the chapter there for development of AI systems or complex models to be able to predict the condition of given complex engineering systems. And then that threw up a whole load of questions and a whole load of issues that came out of that.
So what kind of, I mean, obviously I know because I wrote the paper with you, but just for our listeners, do you want to kind of give us the gist of what the main kind of challenges and problems were that drove this paper?
Yeah, of course. So a lot of the things that drive what we were looking at in this paper is understanding the relationship between the operator and the system itself, and understanding where that decision making really lies in that whole process, from system implementation and output from system, and in terms of the in the kind of ethical formats, what the kind of dangers and pitfalls might come out of that as well, in terms of as we move closer and closer to automation and AI systems, whether if we start to move away from the decision making being part of the engineer's remit or the operator's remit, what risks that might pose.
So when we kind of worked through this, we worked from some basic concepts that encompass things like a simple gearbox example, and then what we did was we worked up to implementation of these systems that are developed by academia into industry. And when we looked at the case studies of implementation of either AI systems or complex systems into industry, it was fair to say that we observed a fair amount of failure. And this was down to mostly the operator and computer interaction. Do you want to expand on that a little bit?
Yeah, and I think most of the problems come from understanding context. and how the context changes, because systems are quite often developed in some sort of ideal world, or and the realities are often quite different, and the realities are quite often unpredictable, because the context and the environment changes, in which many systems operate, and there is in most circumstances that you really should be considering that there is an infinite amount of possibilities to the context that the system may be operating in. That becomes even more prominent when we're looking at complex systems, and complex systems which have so many variables and interdependencies, that means that it's hard when you're developing a system that is able to provide some sort of decision making, um, or 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 significant output, that means that you can it's very difficult to predict that when you're actually developing the model. So how does that cope, and what does it mean if you take away the understanding from the operator, um, if we're making a system that is so complex in terms of, perhaps when we look at AI systems, quite often when we think about AI systems, really what we mean is that we're developing a system and a model that is having an input of data, and it is going through a process to give an output, and quite often that what happens in between that input and output isn't going to be understood by the operator. And if we don't understand how it's getting to that output, can we trust that output? How do we trust that output? And if we're talking about engineering systems, um, you know, is there the specialization? Is there the capability in the operator to understand what the system is doing and understand whether that system is right in its output? So it really becomes about that kind of interaction between the operator and the system itself.
One of the large issues that we observed when we went into this paper was the Boeing Air Max disaster, where there was such disconnect between what the operator thought was happening and what the pilot thought was happening and what the autopilot wanted to do, because the autopilot felt that it needed to stay within strict algorithmic bounds, but the operator, or the pilot in this case, wanted to do something different because from their experience they would do something else in that circumstance. And the battle between the pilot and the AI was so intense that actually the aircraft was going up and down, and eventually it crashed because there was no one way that it could go. The two systems were battling each other. When we put these algorithmic systems into complex platforms, we discussed within the paper the difference between the different envelopes of operation, and this was one of the main problems within the Boeing Air Max disaster. Do you want to expand on that a little bit?
Yeah, so it was interesting to look at the development of AI systems and automated systems within control engineering. Although what we had first targeted was looking at maintenance, um, the the potential pitfalls and errors are so magnified within when you develop these type of systems within control engineering. It becomes a really powerful example because, as you've seen with the Boeing Air Max disaster, ultimately that leads to fatalities, and it's a really powerful example because the context had changed and the context had changed around it, and the system was unable to observe that change in context, because it was ultimately just going through its process with the data in. Only the data in was either wrong, or the data in didn't give the full picture. So it is only still going through that process. However, the pilots can quite clearly, or at some point, pick up that the context has changed, i.e., they're losing altitude, things have changing around them, i.e., something's wrong, and then something else needs to change, but the system doesn't necessarily know or see that. Um, the danger is when it becomes more subtle in other systems as well. Will the will the operator even know that the context has changed? And if the system doesn't know the context has changed, or the operator makes the assumption that the machine is doing the right thing under the change of context, how do we know? How do we recognize that? And also talking about how do we, when the context has changed, do we have the ability to be able to override? Do we have the ability to be able to say the the context in which this was designed is no longer valid, so therefore we need to do something different?
And that's quite interesting, because when we look at algorithms as well, especially in complex platforms, we get even more black and white boundaries, where we've got what the regulator says that we need to put into the algorithm, and that's interpreted as the gospel according to the algorithm. Whereas when we actually look into systems outside of the regulatory prescription, there are still safe operating limits, and then there are operating limits that are maybe not as safe, but may need to be used in an emergency. So when a pilot's piloting a plane, they could go right outside what the regulator says, but know that the airframe can survive because they want to get everybody back on the ground safely. If the algorithm constricts them into the regulatory envelope, they've got no chance of actually taking that evasive action, even if it kills the people on board, because the algorithm won't allow them to take it. What are your views on that?
Yeah, so it is important, because as we design something, we're going to design it within a certain envelope, and that envelope is going to be on the assumption of normal operating conditions. Um, but there are times where we find ourselves outside of the normal operating conditions, or times that we need to operate outside of the normal operating conditions because there are more pressing issues um, that is perhaps greater than that one individual system component. So again, it's about being able to for the operator to be able to recognize when that condition exists, and be able to take that decision in order to say, I recognize that we're outside of the normal operating zone, but I am willing to accept that because of X. But if we've got a designed system, is that able to be able to make that decision? Is it able to see that wider context?
And I think this issue of context, it comes up again and again on the podcast, not being able to have that context or experience within an algorithm that is then running a complex system that's responsible for a lot of lives. That's a huge omission, and that can cause huge catastrophes. Do you think that there are ways forward with this algorithmic development for complex platforms in the future?
Absolutely. And I think that it is encouraging. But ultimately, what we need to make sure is on an ethical standpoint, we need to make sure that it is applied in the right way, and that we don't take away the role and the responsibility of the operator and the engineer. And ultimately, the more information that we can provide to the engineer or the operator to be able to make decisions is good. But what we don't want to do is take away the decision making from the engineer or the operator, and taking it out of their hands. And I think that's where we are at, and I think for the foreseeable, that is ultimately where we should remain, at least. And when we're talking about complex systems and systems that may have significant consequences, where context is liable to change, or where the consequences are significant.
Well, that's the end of our time on the podcast. Thank you so much for being a guest today. It's been an absolute pleasure to be able to talk about our research together in this way, and to get your insights on different parts of it. We hope that you'll be back as a guest again. And thank you so much for co-authoring and also for being on a podcast.
No problem. Thank you very much, Marie. Thanks for having me on.